Saxon Algebra Dose, Lesson 111. Ooh, I love it when the numbers make fun patterns. This is a lesson where we're going to take two things that we already know and we're going to mash them up together. We know how to solve coin problems, and we know how to solve, we've recently learned how to solve systems of three equations, right? Where there's an x and a y and a z, and then a plain number too. We're gonna mash those two things together, and we're gonna use three-part systems to solve a word problem. Ready? Here comes a fun thing. Brace yourself, 111.1. Oh my gosh, I love it. There were 26 nickels, dimes, and quarters all together. Okay, that's gonna be one equation. And their value was $2.25. Okay, there's another one. Here comes one more. How many coins of each type were there if there were 10 times as many nickels as quarters? Okay, so that problem has already given me a little bit of a headache. It's a lot of information, and there's a statement about things that are not equal. Oh, yeah, we have a lot to sort out. But what we can see is there are three distinct chunks. There's a quantity statement, there's a value statement, and then there's one more. That's the pattern that we're gonna follow in this type of problem. So let's go back and sort them out one at a time. First, the quantity statement. Remember, that has to do with how many coins there are, but not necessarily what they're worth. The word necessarily should not be in there. Not what they're worth, just the number of coins. There were 26 nickels, dimes, and quarters altogether. Okay, so the number of nickels plus the number of dimes plus the number of quarters equals 26. I feel that. Do you feel that? That's good. Now the next one is about the value. And we know that nickels are worth 5 cents, dimes are worth 10 cents, quarters are worth 25 cents. And that if we write the number with decimals in it, it's going to give us a headache. I mean, it's just going to make more work for us. I guess that gives us a headache. It annoys us. Okay, so let's write the value. 5 times the number of nickels plus 10 times the number of dimes plus 25 times the number of quarters equals $2.25, but we're writing everything in cents instead of dollars, so it's 225. Those are very weird looking twos for me. I guess they look kind of like those. They feel weird to me. Okay, one more. There are 10 times as many nickels as quarters. Remember, these are a billion times easier if you write them as an inequality first. The number of nickels is greater than the number of quarters. Let me read it again and check to make sure I'm right. There are 10 times as many nickels as quarters. Okay, so number of nickels is greater than the number of quarters. 10 times means we have to multiply whichever number is smaller by 10. This is the smaller number. This tells me so. So what I'm gonna do is I'm gonna write it a little backwardsy. I'm gonna multiply that number by 10. That's gonna put us back in balance. All right, these are always tricky. Write the inequality first, please, I beg you. All right, so now we have a system of three equations. It needs a bracket on it, but I guess I can squeeze it in here. Ooh, that turned out really nice. We need to solve it somehow. What I would like to do, there's lots of ways to solve it. The first thing I want to do is I want to substitute. So the first thing I'm going to do is I'm going to substitute 10NQ, this, for number of nickels in, I'm going to write it out, first two equations. There are lots of ways to tackle these problems. I'm doing what seems easiest, and that is let's get rid of the number of nickels right off the bat by substituting this in. And notice I wrote it weird, I wrote it weird here, but I fixed it. Now it looks normal. Okay, so let's go to our first two equations and fix it. It'll be 10 NQ right here plus ND plus NQ equals 26. And then I'll do it here. It'll be 5 times the number of nickels equals 10 NQ. So I'm going to have to distribute this time. 10 ND plus 25 NQ equals 225. Okay, so that's with me substituted in. Now I'm going to combine like terms. So in the first one, I'll have ND, that stays the same. I keep them in order. It's not really necessary, but I like to. Just keep things neat and organized. I'm adding the 10 and the 1. That equals 226. Okay? And then I have to fix the second one. Now this is going to be 50 NQ. And I'm going to add that to the 25 that I have over here. But first I'll write the 10D. ND plus, okay, 50 NQ plus 25 is 75. And that equals, oh wait, look, I made a mistake. This is not 226, it's just 26. This is 225. I'm double checking the number. Since I messed that up, I'm double checking to the story. Yes, this is 26 and this is 225. This is 26, this is 225. All right. So, ignore that. Now I have to find some way to solve these. I see two options right off the bat. We could multiply this top line by minus 10, and then that would cause these to eliminate. Or the other option I quickly see, of course I could eliminate the Q's if I want, but I don't want to try and eliminate the 11 and the 75. I think multiplying this by negative 10 would be super easy. I could substitute instead, and I could rearrange this. I could kick the 11Q, NQ to the other side, and then I could substitute that in here. But I'm going to be honest with you. I think most students feel more comfortable with substitution than they do with elimination. So I'm going to choose the one that I think you would be less likely to choose, just to remind you how easy it is. It's not bad at all, okay? So that's what I'm gonna do, is I'm gonna eliminate. And I'm gonna do that, I'm gonna multiply top by minus 10. And that will eliminate ND. I'll write that there just so you're sure. I'm gonna eliminate here. There's my arrow, right? You look down the columns. I'm going to eliminate the ND by multiplying the top by minus 10. So I'm going to have to go to the next page. Here, you know what I'm going to do? Wait right there. Just wait. This is easier. It won't rip. Okay. Like a heathen, I ripped the spirally bits out, so I got to get those off right away because, you know, I'm not putting up with that. I'm not OCD, but when I care about a detail like that, I care. But I don't always care. Okay. So now I'm going to multiply this top row by minus 10. So that's going to become minus 10 ND. This is going to be minus 110 NQ equals minus 260, right? And then I'm just going to carry this one down. Plus 75 NQ equals 225. Okay, so there's my new system, right? The second one I just carried along, the top one I multiplied. Now, I don't need that anymore. Now I'm ready to add these, aren't I? This cancels. This becomes, let's see, if it was 100, the difference would be 25, so it's 35. NQ equals, and what's the difference between these two? Oh, it's negative, right? And then this is also negative 35. Oh, John, thank you. So the number, I'm going to write this little chart here. Number of nickels, number of dimes, number of quarters. The number of quarters equals 1. Yay! That was nice, right? Now we have to find something to plug in. I need an equation that has quarters and then just one other thing. So let me go here and see what I've got. Okay, this will work nicely, right? The number of dimes equals, I'm copying this equation because I want to plug my number of quarters into it. So number of dimes plus 11 times the number of quarters, which is 1, equals 26. So if I subtract 11 from both sides, I'll get that the number of dimes equals 15. That all cancels. Ever say a word sometimes and then it suddenly sounds wrong? Cancels. That sounds wrong to me. Number of dimes equals 15. Beautiful. And then we know, this is my favorite one to use, if we go back to the very beginning, they have to add up to 26, don't they? So my brain can do that without an equation. I know these have to add to 26. This is 16, so this has to be 10. And I can just double check by adding these 6 and 2. Beautiful, it works. So here are my answers. Remember when we have a story context to our problem, we don't need to write the answer as an ordered triple because that doesn't make logical sense with this problem. This is the way, this is the answer that we're looking for, is the number of each thing. So that is, we're done. We don't have to go any further. All right, makes sense? We mashed up what we know about coin problems with what we know about 3 systems of equality, 3 statements of equality, 3 systems of equations. That's what I'm trying to say. Yay. Let's go on and do the second problem. I'm going to start it on a fresh page. Example 111.2. This is the only other problem in this lesson. Again, we're going to have a quantity statement, and we're going to have a value statement, and then we're going to have one more. Okay, you can be guaranteed that. It might, like this problem, not exactly be coins, but it'll be close. All right, the total number of blues, greens, and yellows in the pot was 7. Okay, so they're like marbles or something. The blues weighed 1 pound each, the greens weighed 4 pounds each, and the yellows weighed 5 pounds each. Okay, so that's gonna be kind of like their value, right? It's their weight. The total weight was 25 pounds. Okay, good, we'll be able to add that up. If there was one more yellow than green, how many of each were there? All right. I'm gonna violate John's subscript rule of thumb. You know, usually he does this thing where he makes the variables number of nickels, number of dimes, number of quarters. That's fine. I'm not anti that, but sometimes it just feels like extra. So this one I'm gonna do differently, and I'm going to just use blue, green, and yellow without the subscripts. Number of blue, number of green, number of yellow. I'll just have to remember that that represents the number of each, which is what I want anyway, so it's fine. Okay, the total number of blues, greens, and yellows in the pot was 7. So blues plus greens plus yellows equals 7. Now the weights. The blues weighed 1 pound each. I technically don't even have to write that one, but I'm going to do it just so I remind myself that, yeah, you did multiply it out. The greens weigh 4 pounds each, and the yellows weigh 5 pounds each. I feel like it's bowling balls. The total weight was 25 pounds. No decimals, holla. If there was one more yellow than green, okay, so there's more yellows than greens, right? I write the inequality first, and then I balance it. there's one more yellow than greens. So we have to add 1 to the little side, right? Because this is less than, this is greater than. If I add 1 to this side, then I'm in balance. Beautiful, I love it. All right, so there are our 3 statements. Let's follow the same pattern that we did last time. Let's take this, we'll substitute y equals g plus 1 into the top 2. You can call them A, B, and C if you want, but you don't have to. All right, so we're going to substitute this into the top one. All right, so we're looking for the y's. There's a y, and there's a y. Okay, so the first one is going to be b plus g plus, okay, this y is going to turn into g plus 1 equals 7. All right. We'll clean it up in the next round. Now we'll substitute this into the second one. So it's going to be, I'm going to drop off this 1. I don't need it. Plus 4g, sounds like a Verizon ad, plus 5 times the y is g plus 1. So I have to substitute that in here. And all that equals 25. Okay, now we have successfully used this equation. We won't need it anymore. All right, now I have to clean up my like terms, right? So we're gonna have, I'm gonna subtract this 1 and I'm gonna put those 2 g's together. So I'm gonna have b plus 2g equals, I'm subtracting, right? I'm doing it in my head. If you want, you can just make a little note to yourself. It'll be 6. All right. This one we have to distribute. It's going to be 5g plus 5, right? Once we distribute that. Now I'm going to cancel that. Now I'm going to mentally, I'm going to add like terms and I'm going to swim that 5 over. So I'm going to have b plus 9g equals, okay, I'm swimming the 5, 20. Oh, this looks good, doesn't it? I can see that as I look down my columns and look for something to eliminate, again, I'm going to choose elimination because, again, I think most students feel really comfortable with substitution. You could easily rearrange either one of these to make b equals 6 minus 2g and substitute it in here and solve it. That's easy. I'm going to go ahead and use elimination again to just give you more practice with that. I would like to multiply. Now, we could multiply the top equation or the bottom equation by minus 1. Either one would get these b's to cancel. That's what I'm trying to do. So I look at the other numbers and say, do I have a preference as to which one gets the negatives? And I can see that this top equation has the smaller numbers. So if I make this minus 2g and minus 6, when I combine, they'll be positive. I'd rather keep it positive. So I'm going to multiply the top by minus 1 to eliminate b. All right, so here we go. That's going to be like that. It's pretty easy. I don't have to really write this out. So it's going to be minus b minus 2g equals minus 6. And then this bottom one stays the same. This cancels, and I get 7g equals 14. Are you kidding me right now? G equals 2. Thank you, John. He's so good to us, isn't he? All right. So I'll start my list on the next page. Let's see, I need fresh paper this way. So we got that, let's see, it's B, G, and Y, right? Are our colors. And we got that G equals 2. Now, I barely even have to put my pencil to paper on this. If g is 2, y equals g plus 1, so y equals 3. And then all of them have to add up to 7. So that means this, that's 5, and they have to add up to 7. So the number of blues must also be 2. Okay, for this one we knew that we solved for g, and then we know that y equals g plus 1, and then we know that b plus g plus y equals 7. So that's how we did this one first, then we did this one, then we did that one. This is the right answer. They add up to 7, right? 4, 5, 6, 7. Yes. Yippee-yi-yo, kaye. We're done with that one. And there are just the 2 of them, all right? So let me just give you a reminder, not a caution. In all 3 of these, what we did was we wrote out the quantity and the value statements, then the one more. The one more turned out to be a very simple equation, and we used that to substitute first into the top 2 to wipe out one of the variables. Then we were down to just 2 variables, and I chose to eliminate both times. You could substitute. But the moral of the story is use this one more equation to simplify the top 2, to get you down to 2 variables in the top 2, which is what we did here, right? We substituted it in. And then from there, it's quite straightforward and you know what to do. Lesson 11 is done. Thank you. Goodbye.